And yeah, there is no homework question. Okay, let us go with the next 11th one. So in the 11th structure, I'm going to take one 6-membered ring and one benzene. Right. So now the question is, this is also, there is no alkyl group, there is no chain. Okay, so this is also ring, this is also ring. This is 6-membered ring, this is 6-membered ring. Now the question is, which should be taken as a parent carbon chain and which should be taken as a substituent. Whenever you get the competition between normal ring and benzene ring, choose benzene ring as a parent carbon chain, and remaining this one you should not take as a parent carbon. That means this part is acting as our substituent. So if you start giving numbering, this is the first one. So primary prefix, secondary prefix, root word, primary suffix, secondary suffix. So here we can see that there is a primary prefix is there at which position? First position. So what you can write, one cyclo, 6-membered ring is hexyl. Next, there is no substituent, okay, or branches. Root word is what? There is no primary suffix. Completely, you can take it. There is no secondary suffix. So this root word, everything you can take it as what? Benzene. So what we can call one cyclohexyl benzene. One cyclohexyl benzene. Now, moving to the next one. This is very, very important. Right. So let us see here which one will be acting as a parent carbon chain. Okay. So now we have total 3-membered ring outside, and in the here we have one carbon. Okay. So as you know, I said whenever you choose parent carbon chain, okay, the first priority should be what? While choosing the parent carbon chain, the first priority is functional group. After functional group, multiple bond. After multiple bond, maximum number of carbons, then you have to go for substituent. So now there is a doubt that, ma'am, should I take this one as a parent carbon chain or ring as a parent carbon chain? So always remember, take ring as a parent carbon chain, because this is just a functional group. Okay, this is not a chain. Okay, what is the meaning of full form of PCC? Parent carbon chain. Okay, so when you see the carboxylic acid, C double bond O OH, there is no chain here. So hence whenever you get one functional group with a ring, always choose what? Ring. Okay, so what you have learned here, whenever you get one functional group and one ring, so which one you will choose as a parent carbon chain? One ring will be acting as a parent carbon chain. Right, so can I take this as a first number? Okay, second and third. Right. So now what happened while writing IUPAC name? What is the order of writing IUPAC name? Primary prefix, secondary prefix, root word, primary suffix, secondary suffix. Okay, can say there is no substituent. This is acting as our functional group, right? There is no substituent. Root word is what? Cyclo. Okay, cyclo, and 3-membered ring is there. So cycloprop. Okay, next primary suffix is ane. Okay, cyclopropane. Can I call oic acid cyclopropanoic acid or cyclopropane carboxylic acid? Which one is the correct one? Should I write carboxylic acid or propanoic acid? Can I call carboxylic acid? Now the question is, ma'am, why are you using the term carboxylic acid? Can I say here functional group carbon is not involved in the parent carbon chain? As I taught in the last classes, whenever the functional group carbon is involved in the parent carbon chain, then you have to use oic acid. If it is not involved, then you have to use carboxylic acid term. So therefore, IUPAC name is what? Cyclopropane carboxylic acid. Right. Moving to the next one. 12th one is done. Okay. Next question number 13. Right. So if you see here, outside there are only 2 carbons, so there is no chance of having parent carbon chain outside. So hence can I say the ring itself is acting as our parent carbon chain. So ring itself is acting as a parent carbon chain. Okay. Now coming to the next one, functional group. Can say this is a ketone functional group, R C double bond O R. Okay, and this is a methyl group substituent. Methyl group substituent. Can say this is our functional group, right? So parent carbon chain is done. While numbering, first priority should be given for functional group. So I will write it as a 1. Okay, while numbering, what is the order of numbering? Functional group greater than multiple bond greater than substituent, right? So now should I give next number to A direction or B direction? Should I choose A direction but not B direction? Because multiple bond should be get the first priority. So hence I will write here 2, 3, 4, 5 and 6. Okay, right. So therefore now numbering is done. Let us write the IUPAC name: primary prefix, secondary prefix, root word, primary suffix, secondary suffix. So let us try to understand here. Primary prefix is not there. Secondary prefix is there. At which position? 5th position and 6th position, and both are same. So what should I write? 5, 6 dimethyl. Dimethyl. Next root word. Can I say this is a cyclohex? So what I will write? Cyclohex. Okay. Primary suffix is what? In. Alkene is there. At which position? Second position. Hex 2 in. Next, what is the functional group? Ketone. Ketone means ONE. On. 2 hexene 1 one. So this is the name of the compound. 5, 6 dimethyl hex 2 in 1 ol. Next, 14th one. Right. So in this structure, you got one ring and there is one functional group. So which one will be our parent carbon chain? Ring will be our parent carbon chain. So hence this will be acting as what? Ring. Can say 4-membered ring, and this is our functional group. Right. Which functional group? Can say it is a aldehyde. Okay. Next, let us try to write numbering 1. Okay. So remaining 2 yet everywhere you can, anywhere you can give. Primary prefix, secondary prefix, root word, primary suffix, secondary suffix. There is no cyclo bicyclo. There is no substituent. What about the root word? Cyclobute. Cyclobute. Primary suffix in cyclobutane. Okay, now secondary suffix is what? Aldehyde. So listen, CHO, aldehyde. Whenever you get aldehyde, check whether it is a suffix or prefix. Okay, so whenever it is a prefix, you have to use the term formyl. Okay, so whenever it is a suffix, check whether it is involved in parent carbon chain or it is not involved in parent carbon chain. If it is involved in parent carbon chain, you have to use AL letter, all. If it is not involved in parent carbon chain, then you have to say carbaldehyde. Carbaldehyde. Right. So when we people observe, can it's a functional group. Functional is nothing but secondary suffix. So it is acting as a suffix now. But within the suffix, is it involved under parent carbon chain? No, this carbon is not included in the parent carbon chain. Hence, you should use the term al or carbaldehyde. Carbaldehyde. So what is the name of the compound? Cyclobutane carbaldehyde. Cyclobutane carbaldehyde. Next, 15th one. Right. So can say this is here acting as a functional group. Which functional group? Alcohol. So coming to the parent carbon chain, can say this is our parent carbon chain. Right. And if you start giving numbering, this should be get the first number. So primary prefix, secondary prefix, root word, primary suffix, secondary suffix. Right. So here what happened? Primary prefix, there is no cyclo bicyclo. Secondary prefix, there is no substituent. Root word is there. Can say cyclohex. cyclohex, 6-membered. Okay, next primary suffix is alkane, so cyclohexane. Secondary suffix is what? Alcohol, so cyclohexane 1-ol, cyclohexanol. Next 16th one, CH. Right. So when you try to elaborate the structure, okay, so this is nothing but benzene with the C, double bond O, H. Can say this is nothing but our aldehyde group. Okay. Now, so when you go for the, in the starting, in the introduction class, I taught you about benzene with the 0 hydrogen. If this carbon has 0, then you should call benzol, benzoyl. Okay, benzal, benzyl. There are total 3 terms. What are those 3 terms? Benzyl. Okay. Next, benzal. Next, benzoyl. Benzoyl. Benzyl chloride. If the benzene attached carbon has 2 hydrogens. Benzal, when you have to use, if the carbon attached to benzene has only 1 hydrogen. Benzol, when you use, whenever the carbon which is attached to benzene has 0 hydrogen. Can say carbon attached to benzene, it has only 1 hydrogen, so should I start with benzal? Since it is a aldehyde group, so IUPAC name or common name both are same. What you should call benzaldehyde. Next, 17th one. Right. So coming to this group, so obviously benzene ring is acting as a parent carbon chain. So if I choose carbon, can say benzene cannot be used here. So therefore you are not including carboxylic acid. I'm just giving numbering 1, 2, 3. Can say this is a functional group. This is a substituent, right? So let us see here, primary prefix, secondary prefix, root word, primary suffix, secondary suffix. Okay, primary prefix is cyclo bicyclo, it's not there. Secondary prefix is there at which position? Third position. So 3-nitro. Next root word is what? Benzene. Okay, so what we can write? 3-nitro benzoic acid. Okay, root word and primary suffix is benzene, secondary suffix is oic acid. Now you will get it out that, ma'am, this parent carbon chain, this carbon is not involved, right? So when this carbon is not involved in parent carbon chain, then we have to use the term carboxylic acid. But you are using here benzoic acid. Better this topic, this concept is not applicable for benzene. For benzene, directly functional group is you have to mix here. Okay, right. Next, 18th one. Next, this is what IUPAC name. If I talk about common name, so when you go for common name, for example, if something is attached at this position, then this is called ipso. This point you should call it as what? This position you should call ipso. Okay, so the point which is next to this ipso is what? Ortho. Next to ortho is meta. Next to meta is para. Okay, so since nitrogen is present at meta position, so what is the other name of this compound? Meta-nitrobenzoic acid. Meta-nitrobenzoic acid. So this term meta, ortho, meta, para. Okay, this is one concept. The concept ortho, meta, para, this term should be included while writing common name. Whereas in IUPAC name, you have to include the numbers. Okay, right. Moving to the next one, 18th one. Next, 19th one. Okay, suppose this is our main part. Can say this is our ipso. Can say this is nothing but ortho. This is meta. Okay, right? So if I give numbering 1, 2, 1, 2, 3. So what is the name of the compound? Okay, can I call 1 comma 2? Can I say both are substituent? Okay, halogens are always substituent. They will never act as a functional group, right? So when you are writing the IUPAC name for this compound, okay, when we are writing primary prefix, secondary prefix, root word, primary suffix, secondary suffix. Okay, there is no functional group, there is no cyclo bicyclo, but there is a substituent, two substituents at which position? 1 comma 2. So 1 comma 2 dichloro. What is the root word and primary suffix? Benzene. So 1 comma 2 dichlorobenzene. This is IUPAC. Okay, but if I go with common name, so what will be the common name? Can say ortho is there, right? So what you should call ortho dichlorobenzene. Dichlorobenzene. Take this one as homework. 19th one. Right. Let us go with the next last topic of IUPAC name for the bicyclo and spiro compounds. Bicyclo and spiro compounds. Let us try to understand what is like bicyclo and spiro compounds. Okay, so generally let us write we will write in the form of differences. Okay, one side we are going to write bicyclo, other side we are going to write spiro. So first of all, what is how to understand the given is a bicycle. Okay, if two cyclic rings are attached to each other, okay, if two cyclic rings are attached to each other, then we should call bicyclo, two cyclic. Okay, if two cyclic rings, okay, if two cyclic ring, can I say this is one ring, this is also one ring. If two cyclic, okay, first I will draw the structure, then you can understand more clearly. Okay, right. Can say these two are also ring. Here also we have two rings. If two rings have one common point, then you should call what? Spiro. If two ring has two common points, then we should call bicycle. I hope you understood clarity between the how to identify whether the example is a bicycle example or spiro example. Right? Bicycle is nothing but two cyclic rings have two common points. Spiro means two cyclic rings having only one common point. Okay. Let us see how to write the IUPAC name for bicyclo compound, how to write IUPAC name for spiro compounds. Okay, right. So let us try to understand. So the first of all, what you have to do, numbering should be followed. Write down. Numbering should be followed. Along large ring, including bridge carbon. Including bridge carbon. Next, coming to here, numbering should be followed. Numbering should be followed along small ring, should not include bridge carbon, should not include bridge carbon. Okay, so for example, what is the meaning of bridge carbon? Can I say these red color dots are there? No, this you should call bridge carbon. The carbon which hold the two rings, the carbon which hold two rings, that carbons we should call bridge carbon. Okay, right. So let us go with the next second point. After numbering, what is the next point? Let us try. First, let me give a small example of numbering. Then we'll go with the next part. Okay, for example, if I take here Okay, so can I say here two rings are having two common points. Here two rings are having one common point. So hence I will call it as bicyclo. Here I will call it as what? Spirocomp. Okay. Now what they are saying here, numbering should be followed along the larger ring, including bridge carbon. Can I say this is a 4 carbon ring. This is a 5 carbon ring. Yes or no? 4 membered ring, 5 membered ring. So numbering should be first started from higher number of carbon or less number of carbon. Higher number of carbon, right? Now the question is, for example, if I take this one as a pink color, okay, now can I say the 5 membered ring has total 3 pink color carbons and 2 red color carbons. Now the question is, should I start from smaller ring or larger ring? Obviously I have to start with larger ring, but should I start from the bridge carbon or should I start from pink carbon? So what they are saying, including bridge carbon, that means I have to start with which carbon? Bridge carbon. So which is nothing but 1 2 3 4 5 6 7. Okay, whereas coming to spiro, numbering should be followed along small ring. Can say this is 4 membered ring, this is 5 membered ring, right? Should I start with 4 membered or 5 membered? I have to go with 4 member, because here they are saying that small ring, right? But should I start now? The question is 4 member means can say there are total 3 pink carbons and 1 red carbon. Now the question is, should I start from red carbon or pink carbon? I have they what they are saying, should not include the bridge carbon. That means numbering should be done only for from where? Without bridge carbon. Okay, so what you will get? 1 2 3 4 5 6 7 8. Here you can write should not start with the bridge carbon. Better you write should not start with the bridge carbon. Okay, whereas here start with bridge carbon. Don't say include, better will say start. Okay, done. Understood the numbering method, right? Let us go with the next second one. Okay, so the second step is what? In the brackets, okay, you have to write ring, you have to write bridge, you have to write ring. Okay, so and this should be written in the decreasing order. Okay, next coming to here, second point, how you are going to write? Here you are going to write ring dot ring. Okay, and this must be ascending order. So let me try to explain you what is example. Okay, so I will just remove this number, otherwise you'll get confused. Okay, now let me try to explain you how to write the bracket part. Okay, so they are saying that in the bicyclic we have to write ring dot bridge dot ring. Okay, sorry, it's not bridge. You can take anything. Okay, uh, comma, better you keep comma. Okay, right, so whatever you are writing, you have to include what? Ring, ring, bridge. All the three you have to include. What are the three things you have to include here? Ring, bridge, ring. Okay, it's a descending order. Number. Okay, just let me explain. Okay, see, the order should be in the decreasing order. For let me try to explain you. For example, in this ring, okay, left ring, for example, I'm writing here left ring, bridge, and right ring. Okay, so you answer me. Just left ring has total how many carbons? Left ring is made up of total 2, 1 and 2. How many pink color carbons we have for the left one? 2 carbons, right? So left side we have 2 carbons. Bridge has total how many carbons? 2 carbons. Okay, next right side has total how many carbons? 3 carbon. So decreasing order indicates what? 3 dot 2 dot 2. Sorry, bridge it's 0. Sorry. Why 0? Because do you have any carbon in the middle? There is no carbon in the middle, right? So therefore you can write 3.2.0. Okay, right. So coming to this side, how many carbons here? How many pink color we have? 1, 2, 3, 4. So right side we have total 4 pink color, left side we have 3. So bracket should be written ascending order, that is nothing but 3.4. Okay, there is no, I'm repeating again, there is no rule that you have to write ring, bridge, ring. There is no rule like this. Whatever you are including, include all the 3 values but written in the decreasing order. Next, now coming to the third step, IUPAC. How to write IUPAC here? Bicyclo plus bracket path plus root word. Next, what about here? Syn. How to write IUPAC for spiro compounds? Spiro word plus bracket path plus root word. Okay, so don't worry, we'll do few examples, then you people can understand. So we'll write down the first example. Right. So can I say, first of all, you need to identify this is a cyclocompound, a bicyclo compound. Sorry, bicyclo or spiro. Can I call it as a spiro compound? Why there is a spiro compound? Because there is only one common point. Okay. Next, how to write IUPAC for spiro compounds? Spiro plus bracket path plus root word. Okay. So before writing this, we need to give numbering, right? How to give numbering? For spiro compounds, number should be started from the small ring. Can say this is a 3-membered ring. This is also 3-membered ring. That means you can start from anywhere. While starting, should I include the bridge bond? Should I start with the bridge carbon? No. So therefore 1, 2, 3, 4, 5. Okay. Can I say there are total 5 carbons now? Clear till here? Right. So next, how to write this ascending order or descending order? Ascending order. Okay, so if there are 5 carbons, so hence our root word is what? Pentane. Okay, right. So now the next question is how to write this bracket. So we have to write ascending order. So here total how many pink carbons we have? 2. What about in this ring? 2. So what should I write here? 2.2. So therefore, finally, what is the name of this compound? Spiro in the bracket 2.2 pentane. Next question. Right. Can say the total 2 common points. So hence the structure belongs to bicyclo. How to write IUPAC name for bicyclo? Bicyclo plus bracket plus root word. Okay. So bicyclo term is there. First of all, we want to know root word. How to write root word? Numbering. Okay. So numbering should be started from big, large ring or small ring. We have to start with large ring. Can I say this is a 3-membered ring? This is also 3-membered ring. So you can start from anywhere. Should I start with the bridge carbon without bridge carbon? I have to start with bridge carbon. So 1, 2, 3, 4. So therefore root word will be what can I call? Root word is nothing but butane, 4 carbon. Coming to here, should I have to write a ring, bridge. But all these 3 should be descending order. Okay. So how many pink color carbons you have left side? This ring has how many pink carbon? 1. This side, 1. Between, do you have any carbons? No. So 0. So if you write descending order, so what you should get? 1 dot 1 dot 0. So therefore, what will be the name of this compound? Bicyclo in the bracket 1 dot 1 dot 0. What you should write? Butane. Next, third example. right? Again, there are total 2 points common. So hence the compound is what? Bicyclo compound. How to write IUPAC name for bicyclo? Bicyclo plus bracket plus root word. So while writing root word, always start from what? You need numbering. Okay, how to start numbering? By using large ring. Okay, this is a 3-membered ring, this is a 4-membered ring. So which one is a larger? Fourth one. Should I start with the bridge carbon, without bridge carbon? With the bridge carbon. So 1, 2, 3, 4, 5. So therefore, based on this, we came to know that root word is what? Pentane. Okay, right. Coming to here, we have to include ring, ring, bridge, but all the three should be written in descending order. So here, how many pink color we have? So 1. Okay, whereas here you have 2. Between you have any carbon? 0. So what should be descending? 2.1.0. So therefore, finally, what will be its IUPAC name? Bicyclo bracket 2.1.0 pentane. Next, fourth one. Right. So in this structure, you can see that the two rings are joined by only 1 point. So hence the structure belongs to Spiro compound. How to write IUPAC name for Spiro compound? Spiro plus bracket plus root word. Okay. How to get the root word? By numbering. How to start the numbering? By using small ring. Okay, so this is 3-membered ring, this is 4-membered ring, right? So that means I have to start numbering from 3-member. But should I start with bridge, without bridge? Okay, we have to start with without bridge. So hence 1, 2, 3, 4, 5, 6. Okay, right. So that means the name, based on this, we came to know that root word is nothing but hexane. Okay, coming to bracket, you have to include only ring and ring, not bridge, but both should be written in ascending order. Right, so here how many pink color carbons we have? 2. What about here? 3. So therefore in the bracket you have to write 2.3. Okay, so therefore finally how to write its IUPAC name? Spiro bracket 2.3 close the bracket hexane. Next last example. So this is nothing but, if you try to write how many carbons? 1, 2, 3, 4, 5, 6. There is a 6-membered ring. So which is nothing but like this. Okay. So between the ring, you have total, between this ring, there is one joining having 2 carbons. So that joining having 2 carbons will be pink color like this. I hope understood the structure. I just elaborated this. Okay, so can I say there are more than 2, there is a 2 common points between them, between 2 rings. This is 1 ring, right? So there are 2 common points, means this is nothing but what? Bicyclo compound. How to write IUPAC name for bicyclo? Bicyclo bracket plus root word. Okay, how to start the root word? You have to start with numbering. How to start numbering? You have to choose large ring. Can say this is 1, 2, 3, 4, 5, 6-membered ring. This is also 6-membered ring. So you can start from anywhere. Both are same. But should I start with bridge? Yes. So therefore 1, 2, 3, 4, 5, 6. So hence can I say the root based on this root word is nothing but hexane. Right, next moving to the bridge, and we are going to write the number of carbons for this structure. Okay, so let us see left side. First of all, bridge has total 2 pink carbons. Bridge, so I will write here 2. Left side, how many you have remaining? 1, 2. What about here? 2. Okay, so 2.2.2. So therefore finally what is the name of the compound? Bicyclo 2.2.2 hexane.